Problem 6b. We have a fourth degree polynomial. It tells us we have two zeros, x equals 2, x equals -1. We use synthetic division in this fact to help us find the other zeros, and we want to list them and do the complete factorization. So we have two things to accomplish here. Now I want to just to give a little context to this, show this graph. This is the graph of the function in question, and notice it's fourth degree. If we look at the graph, we have one term and two zeros. Now that might seem to indicate we have a second degree polynomial, like a parabola. If you look carefully at this, though, it's not quite, it's a little hard to see, but it doesn't seem to be symmetric. And a parabola is always symmetric. So, given that fact, I'd just point out, there's a zero there, here's a zero here. We do have these two zeros, these two x-intercepts, -1 and 2, and we want to be sure to find the other. Apparently there are two more zeros, but they must be complex if we're only seeing two zeros here. Of course, there may be other terms in this graph, but it doesn't appear so. So what we do is we will start off with synthetic division. Synthetic division is a nice quick way to do polynomial division with zeros. So I'm bringing my coefficients down, and I'm going to do division. This is going to leave me with a new polynomial of third degree. We'll take the 2, bring down the 1. 2 times 1 is 2, add, I have 1. 2 times 1 is 2, add, I get 9. 2 times 9 is 18, add, I get 9. 2 times 9 is 18, add, I get 0. This is my remainder. It's also the value of the function when x equals 2, and we saw that it was 2, 0. Kind of cool. Now, don't start over. Just continue with this new set of coefficients. This would represent x cubed plus x squared plus 9x plus 9. From the graph, we know that -1 should be a 0. So we'll bring down 1. -1 times 1 is -1. Add, we get 0. -1 times 0 is 0. Add, we get 9. -1 times 9 is -9. Add, we get 0, which is what we expect. Now, this is representing coefficients of a squaring or a quadratic equation, or a quadratic expression. And it represents x squared plus 0, x plus 9. If we're going to find the zeros, we can just write that as x squared plus 9 equals 0. And we want to find the zeros for this quadratic. And we can do the square root, kind of complete the square. We always put this value over on the right if we're going to do this by extracting square roots. Subtract 9 from both sides. We get x squared is equal to -9. Square root of each side, plus or minus over here. It's a little hard to see. Sorry about that. Let's do it. -9. Take a square root of both sides. And we get x is equal to plus or minus the square root of 9, and there was a -1 times 9. Square root of -1 is I. So this is equal to plus or minus 3i. So our list of all zeros. The list of all the zeros was, well, what we were given, 2, -1, 3i, -3i. And the complete factorization would be f of x. And we just turn these zeros into factors. X plus 2, x minus 2, x plus 1, x minus 3i, and x plus 3i. This is the complete factorization.